Okay, so today we are looking at laws of exponents, and in particular we're just looking at product of powers. So first thing is, when we think about exponents, the number here is called your base. The smaller number, that's your exponent, and this entire thing is called a power. So in particular today we're going to be talking about product of powers. So I'm going to move this out of the way. For part 1 we're looking at a to the 4th, b to the 7th times a squared times b cubed, and we want to write those without using exponents. So I'm just going to write them out by how many there are. So a to the 4th means you're multiplying a times itself 4 times. So a times a times a times a. B to the 7th, same thing, so we're going to have 7 b's. 6, 7. And I'm going to write out the other one, a squared and b cubed. So here we are. It's written without exponents. Now we want to know, for part A, how many a's are being multiplied together. So if I go through and I add, I have 4 here and I have 2 here. So I have 6 total. Then b's, there are 7 here, 3 here, so I have 10 total. So using these new numbers in part B, we're going to rewrite our expression. So we have a to the 6th, b to the 10th. There's our new expression. Now if we look at example 2, I want to write 5 times m to the 4th n squared. All of that times 3m cubed n. And I want to write it again without using exponents. So 5, there are 4 m's, 2 n's, and then we have a 3, and 3 m's, and 1 n. So now if we total how many m's are being multiplied, there are 4 and 3, so 7. And how many n's there are 2 and 1, so 3. Alright, and then when we rewrite our expression, the only difference between this one and the first one was we have numbers out front. So 5 times 3, I'm going to multiply it like normal, so 5 times 3 is 15. And then my new exponents are 7 and 3. So my final answer was 15m 7th n cubed. Now, if we look at question 1 and question 2, what patterns do you notice? Well, if you notice that our exponents got larger, so because we were multiplying them out, we ended up adding the exponents, if you notice that. So then if we want to generalize a rule about multiplying expressions of like bases, so the product of power they have to have the same bases. So like this, they had the same A's, they had the same B's, same M's, same N's, whatever. If they have the same bases, then the product of power tells us that we have to add their exponents. So we're going to try out that new rule with a few more examples. I'm going to do the first one and second one with y'all, and then I want y'all to pause the video and try the 3rd, 4th, and 5th on your own, and then check them like we do in class. So on example 3, I'm going to add the exponents. If there's not an exponent on the base, that implies that there's a 1 there. Okay, so you have to make sure you count that. So 3 and 1, so there's 4 x's, 6 y's, 2 y's, so 8 y's, 2 z's, and 7 z's, so 9 z's. So then that is going to be your answer for the example 3. Now example 4, when we multiply, I'm going to multiply the numbers. So 4 times 6 is 24. There are 3 x's and 7 x's, so there are 10 x's total. So there is your final answer on that one. So here's where I would like you to pause, try 5, 6, and 7 on your own, and then check back. So when we multiply, we get negative 2 times 3 times 5 is negative 30. There are 1, 11, 2, so 14 x's. On 6, 7 times negative 1 times 2 is negative 14. 4 plus 2 plus 1 is 7. And then 1 plus 2 plus 1 is 4. So that final answer is negative 14, x to the 7th, y to the 4th. Example 7, negative 2 times 4 times negative 3 is 24. There's 3, none, 5, so 8 x's, 9 and 1, and 10 y's. So your final answer on that is 24, x to the 8th, y to the 10th. So there is product of powers. After you finish this, I want you to go through and I want you to put what questions you have, what did you find confusing, and what did you learn. And we'll discuss those things in class tomorrow.